Hello and welcome to this week's edition of Labrats. So last week we learned about types of matter. We learned that all of the universe and the world and our solar system is made up of tiny little particles called matter, and they make up all the things in the world and the universe around us. So we learned that there are three states of matter. We learned there are solids, liquids, and gases, and they have different properties. We learned that in solids, those tiny little particles that make them up are really closely packed together and they can't move, they're super rigid. And in liquids, we learned that those particles expand, so they get further apart, which causes them to expand, right? So if you can imagine a bunch of marbles closely packed together, that's a solid. If we move them a little bit further apart, that's like a liquid. So they're able to flow and move and manipulate, and that's why water has all the properties that it does as a water. Then we learned about gases, and we learned that gases, the particles were even further apart, which makes them even more, manipulatable and how they're able to float in space and stuff like that. And that's when we blew up the balloon and, used the water vapor coming from our breath as a way of showing that. There was a lot less water in the vapor, but it occupied so much more space. So as things get colder, they tend to, the particles get closer and closer together, which turns them from a gas into a liquid eventually, and then if they get cold enough, they'll turn into a solid. And something that changes with that is the density. So density is defined as how much mass there is in a particular space. So we're gonna do a little bit of an experiment to understand density. So this week we're gonna have 2 cups, and we're gonna put half a cup of water in each, okay? And this one, we're just gonna leave it as water. In this one, we're actually gonna add sugar to make liquid sugar. So I gave you 5.5 tablespoons, and what you do is you just slowly add the sugar to your water, and you stir it up because we want to make liquid sugar. So if you stir it and stir it and stir it and stir it, eventually all of the crystals, which are a solid, it's tiny little particles of sugar, that solid is going to dissolve in the water to create liquid sugar. If we add enough sugar to this, we will create liquid sugar. And if you keep stirring it and stirring it and stirring it, you'll notice that all of the little particles of sugar dissolve. So we're just gonna add that sugar right in, and we're gonna stir and stir and stir. I gave you the perfect amount to create liquid sugar, essentially. So enough sugar to cause it to be a liquid sugar. And you'll notice another thing that happens as we added the sugar is that all of a sudden we have more liquid. And that's because as we added the sugar, we increased the volume. So volume is defined as essentially how much space is being taken up by a liquid. Usually is how we think of volume. So this is a really good example of how, as we added the sugar to this, we increased the volume. So we're gonna stir and stir and stir until we've basically created liquid sugar. We even have to keep stirring more. So this does take a little bit of time, but we want to completely dissolve all that sugar in this. And if you do this, you'll notice that the properties of this change because it's no longer just water, it's sugar and water. You'll notice that that this substance is actually kind of thicker. So that's a property of liquid sugar. So we want to understand density and we want to understand, like, our hypothesis is essentially that if solids shrink and all the particles get tighter and closer together, that the solid should be denser. There should be more mass in that tiny little cube of sugar than there should be in this water, right? Because all the particles are further apart. So we're hypothesizing that if we drop ice and a cube of sugar into these solutions, that both of them should sink to the bottom because the solids are always denser, right? So regardless of your solution, if you had liquid iron for instance and dropped a cube of iron inside, it'll sink to the bottom. So that we're going to demonstrate this right now. We're going to drop a cube of ice and a cube of sugar into this. So let's drop our sugar cube, and we've proven our hypothesis, right? our sugar cube dropped to the bottom, and that's because the sugar is more dense than the liquid sugar. Because in a liquid sugar, the particles are further apart. In a solid, they're closer together, so it's heavier per the size, right? It's heavier per the size. So we're gonna do the same thing now with our water. And we've just disproven our hypothesis here. The solid version, the crystal version of water, which is ice, actually floats on top, which is the exact opposite of basically every other substance known to humanity in science. And if it wasn't for water having this really, really unique property of doing this, life on Earth would not be possible. And you might be wondering, well, why is that? That's because 2 billion years ago, life on Earth started as bacteria in the oceans. And if water behaved the way that every other solid behaves, like that, you know, look at our sugar cube here. You'll also notice that our sugar cube isn't dissolving. That's because there's so much sugar in this that it's not going to dissolve. That's another thing that we can talk about at a different point in time. So if water behaved like this sugar, in that the frozen, the solid of water, you know, sank to the bottom, essentially what would end up happening is lakes and oceans would actually freeze from the bottom up. And we know that that's not how it works. They form a layer on top that's ice, and then everything is water below that. And that's how animals and plants are actually able to live and exist in oceans and lakes when it's freezing out, because water doesn't behave the way every other substance does. So this is actually entirely the reason why life on Earth is possible. If water behaved like, you know, every other substance, like the sugar that we're looking at here, life would not be possible, because our water would freeze from the bottom upwards, and it would kill everything in the lakes and oceans that existed. So another thing that you can do with this is we're gonna add a couple drops of food coloring to some of this liquid sugar to demonstrate something else here, where we're gonna take this experiment next week. So here we're gonna use red just for fun. You can use whatever color you want, but we want it to be very, very saturated with color. Saturated just means that there's lots of color in it. So we're gonna pour this in like that. Okay, and then we're gonna take some of this water and we're gonna dye it a different color. It's very important that you dye it a different color, okay? So we're gonna dye it blue. We're gonna dye this water blue. Okay, we're gonna stir it up. We'll get this out of the way here. And what we can do is we'll tilt this at a 45-degree angle, and you'll notice something very interesting happens. Notice how they don't mix. This is another example of liquid density, and we're going to do some experiments with liquid density next week and play around with this and see exactly how density works in liquids. Isn't that neat? All right, so I'll see you guys next week when we talk about density of liquids. And if you have any questions, leave them in the comments section, and I'll see you next week.